Alright, today we're going to do some problems on changes in states of matter. What that basically means is that whenever a substance goes from a solid to a liquid, or a liquid to a solid, or a liquid to a vapor, or a vapor to a solid, or something like that. And basically, whenever you do that, whenever you have a substance that has these changes in states of matter, there are qualities for that change in state. For instance, for water changing to liquid, it uses 334 joules per gram. So that's kind of what I mean. There's a chart that has all kinds of different elements and substance and their changes of matter, and it's very readily available online or in most chemistry books in the back. But let's do some problems here with this. What I would highly recommend ahead of time is, if you haven't already watched the video at khanacademy.org on changes in states of matter, that you pause this, go watch that, and come back. I'm going to be solving some problems using dimensional analysis, assuming that you have the already needed intuition from his videos that he gives to do these problems. Alright, so let's get to it. Alright, this problem is one of the simpler, not necessarily easier, but simpler problems in changes in states of matter. It says ice cubes at 0 degrees Celsius with a mass of 26 grams are added to your soft drink. How much heat in joules will be absorbed to melt all of the ice at 0 degrees Celsius? So it's giving us the amount of water that we have here. Let me do this in a different color. It's giving us the amount of water that we have here, 26 grams, and it's wanting to know how much heat in joules will be absorbed to melt all the ice. So we just use our equality that I looked up on our chart here. We start with what we're given. We have 26 grams of H2O, and you know what? Let me rewrite this equality here to maybe something that you're familiar to seeing. So we're going to use dimensional analysis to solve for this, right? So this is saying that H2O going to solid going to H2O liquid uses 334 joules per gram. That's the same thing as saying for every 1 gram of H2O going from a solid to a liquid, it takes 334 joules. Or we could write this as for every 334 joules, we have 1 gram of H2O going from a solid to a liquid. Those mean the same thing. So whenever we do a dimensional analysis style problem to solve for this chemistry word problem, we're going to use it one of these two ways, either with the grams on top or the grams on bottom, depending on how we set up our formula. We just want our units to cancel out. We want grams to cancel out, or we want joules to cancel out. So let's start with what we're given, and hopefully that didn't confuse you too much. We're given 26 grams of H2O, and we want to eventually have our units end in joules. So we're going to use this conversion factor here. We're going to use this one because this one has grams on bottom and my grams are on top here. So my grams will cancel out. I'll be left with joules. So I know for every 1 gram of H2O, I have 334 joules. Okay, so that's going to equal blank joules of energy, because my grams of H2O here are going to cancel out. I'm going to be left with joules. So basically all I'm doing at this point is multiplying 26 by 334, dividing that by 1. It's going to give me my answer in joules, which is what I'm looking for.